We have already mentioned in the last video how we may use for all, there exists, etc. to write down a mathematical proof. In this video, we shall go deeper. This language of for alls and there exists has a grammar, a very simple grammar with only a few rules, and the rules have no exception. But first, a little notation. The for alls and there exists are together called quantifiers. Now for the rules of our grammar. Let me split the rules into two categories. First, the structural ones. These will tell you how to construct a sentence in the language of mathematical logic. And second, transformational rules, where we shall learn about how the meaning of a sentence changes when a part of the sentence is transformed. This video will deal exclusively with the structural rules. The transformational ones will come in the next video. We have already encountered rule 1 in the first video. All the quantifiers must be at the start of a sentence. This, for instance, is not allowed because the for all here has come to the end of the sentence. We should have written this like this, with the for all at the beginning. You might think that this rule is rather superficial. Why should we care about whether the quantifiers are written on the left or on the right? Actually, there is good reason why we should care about this rule. Without this rule, you cannot even arrive at a very important rule about order of quantifiers that will come in the next video. It is sad that most books flout this rule, even the internationally acclaimed books like those by Rudin or Apostle. Even there, you will often find that the for alls are pushed all the way to the end. That is because English grammar prefers that format. If we want to say that a statement is true for all men, then in English the phrase for all men occurs at the end. If we blindly imitate English grammar, then we should have this. That is why most English books send all the for alls to the end of the sentence. But in fact, we should have written for all men, the statement is true. In this respect, the grammars of most Indian languages are closer to that of mathematical logic. And another thing, notice how we have used brackets or parentheses in order to group this entire thing after the quantifier. So whenever there is a big thing after a quantifier, it is a good idea to enclose them inside parentheses. It is easier to read that way. When we read a sentence written in the language of mathematical logic and encounter a there exists, we typically say a such that after that. Some people prefer to write the such that as part of the sentence, though that is not essential. For instance, we shall read this as there exists a greater than 0 such that for all b greater than 0 there is c less than 0 such that a not equal to b minus c. But since mathematical logic sentences already tend to be rather long anyway, it is better not to encumber them further with such that's every now and then. It is enough to say the such that's while reading. Anyway, it is now time for the second rule. The second rule is that each quantifier must be followed by a variable and its condition, but there must not be any longer formula there. Let me show this with one example. Here, x and y are the variables and this greater than 0 and belongs to R are the conditions. But if we want to say that all numbers of the form 4n is the double of some even number, then this is not allowed. We can't write 4n and 2m here immediately after quantifiers like this. We could have written like this. Here 4z and 2z stand respectively for the sets of all multiples of 4 and 2. If we want to say that the sum of two real numbers is again a real number, then we may not write like this. Because here this x plus y is a formula that is written after this quantifier. This is not allowed. We should have written like this. For all x in R, for all y in R, x plus y is in R. Suppose we want to say that the number immediately after an even number is an odd number. We know that all even numbers look like 2n and odd numbers like 2n plus 1. So sometimes students may mistakenly write like this. This 2n here is not allowed after the for all. The correct way to write this is, for all n in integers 2n plus 1 is odd. Now you may think that this sentence does not nicely bring out the contrast between even and odd. Then you may write it like this. Here even and odd stand for the sets of even and odd numbers respectively. This example also demonstrates that the same idea may be expressed in more than one way. How you write it has no effect in mathematics. It is just a matter of personal taste. I told you just now that each quantifier must be immediately followed by a variable. The third rule is about those variables. All those variables must be distinct. Consider this. Here, this epsilon and this delta are two distinct variables. But had we written this, then that would have been a mistake, because here we have written epsilon in both the places. The names of the variables are not of any importance, but they must be distinct. We could as well have written this. Here we have written A for epsilon and B in place of delta. That has not changed the meaning in any way. The fourth rule says that the sentence to be proved must have all its variables quantified. This means every variable must have either a for all or an exists before it. This, for example, is not allowed. Here this z is not quantified. Only x and y are quantified. But this pi is not posing any problem because pi is not a variable, it is a constant. Let me share a terminology in this context. Variables that are not quantified are called free. For example, here this z is free. All other variables, that is those that are quantified, are called bound. For instance, here x and y are bound variables. So the fourth rule says that the sentence to be proved must not contain any free variable. All variables present in it must be bound. These are all the structural rules. Not very hard, but still a bit confusing at first. The next video will discuss the transformational rules.